As a species, we are haunted by the prospect of our own destruction. We build bunkers, we monitor the skies, and we run simulations of how the end might come. We fear the sudden violent impact of an asteroid much like the one that ended the reign of the dinosaurs 66 million years ago. We fear the silent, suffocating creep of climate change, the melting of the ice caps, and the rising of the seas. We fear our own nuclear arsenals, the weapons we built to protect ourselves that now hold the power to erase us. These fears are justified. They are the immediate threats to our civilization. But as I have spent years looking past the human timeline and into the deep astronomical data of our solar system, I have realized something profound. Even if we solve every crisis of our own making, even if we stop the warming of the atmosphere, deflect every asteroid, and achieve global peace, it will not save this planet. The end of our world is not going to come from a rogue rock in space or an invisible greenhouse gas. The great demise of life on Earth will be orchestrated by the very thing that made life possible in the first place. The culprit is not a stranger. It is the celestial body we rely on every single day. It is our own sun. Throughout human history and almost every ancient culture, from the Egyptians to the Aztecs, the sun was worshipped as the ultimate creator. The bringer of warmth, the architect of the seasons, the life giver. And they were right. Without the precise distance of the Earth to the sun sitting perfectly within the Goldilocks zone, our planet would be a frozen, dead rock. The finely tuned balance of light and radiation has kept our oceans liquid and our atmosphere breathable for billions of years. But stars, like all things in the universe, are not eternal. They are born, they age, and they die. And our sun is currently in the middle of a very long, very slow transition. To understand why the Earth is doomed, we have to look inside the core of our star. As a main sequence star, the sun is a colossal nuclear fusion reactor. Every single second, it crushes 600 million tons of hydrogen atoms together to form helium. This violent reaction releases the immense energy that bathes our planet in light. But here is the critical flaw in the system. Helium is heavier and denser than hydrogen. As the sun burns through its fuel over millions of years, the core slowly becomes more crowded with helium ash. The core begins to contract under its own immense gravity. As the core shrinks, the pressure and temperature inside it skyrocket. The reaction speeds up, the sun burns hotter, and as a result, it becomes brighter. We think of the Earth as a resilient fortress. It has survived ice ages, supervolcanoes, and asteroid impacts. Life has always found a way to bounce back. But all of that resilience relies on one fundamental condition: that the energy coming from the sun remains relatively stable. The story I am about to tell you is the timeline of our planet's final days. It is a slow-motion apocalypse that will not happen all at once, but in agonizing stages. We will see the continents crash together into a suffocating super landmass. We will witness the bizarre paradox where increased sunlight actually starves the world's plants of the carbon dioxide they need to breathe. We will watch the oceans, the very cradle of life, boil away into the atmosphere, turning Earth into a toxic twin of Venus. And finally, we will look into the distant future, where the physical rock of the Earth itself is consumed in a fiery embrace by the star that gave it life. I am Tann, and this is Y Zone 360. Before the sun can boil our oceans, the Earth will construct its own trap. We are so used to the map of the world as it looks today, 7 continents scattered across a vast blue ocean. But this arrangement is just a brief snapshot in the deep history of our planet. As I trace the trajectory of the Earth's tectonic plates mapping their movements into the deep future, I realized that the first great extinction of this new era won't come from the sky. It will come from the ground beneath our feet. The Earth's crust is a restless machine driven by the intense heat of the mantle below. The plates are always moving, diverging, colliding, and sliding past one another. This movement is incredibly slow, a mere few centimeters a year. What emerges from this slow-motion collision is not a new world, but a very old nightmare. The continents fuse together to form a single colossal supercontinent. Geologists call this future landmass Pangaea Proxima. At first glance, a supercontinent sounds magnificent. I realize that Pangaea Proxima is not a unified paradise, it is a geographic prison. To understand why this is a death sentence, you have to understand how our climate works today. Our current fractured arrangement of continents allows for a complex network of ocean currents. These currents act like the Earth's circulatory system, distributing heat from the equator to the poles and bringing life-giving moisture deep into the continents. But a supercontinent destroys this system. Imagine a vast, hyper-arid desert spanning millions of square miles. There are no rivers, no lakes, and almost no rain. Because the landmass is so large, it heats up much faster than the ocean. Temperatures in the interior would routinely skyrocket past 55 degrees Celsius. During the long, brutal summers, it would be hot enough to kill almost any mammal currently living on Earth today. The massive temperature difference between the superheated land and the surrounding super ocean would generate mega monsoons, catastrophic continent-spanning storms that batter the coastlines but fail to reach the dying interior. This stagnation triggers a deadly chain reaction. Without circulation, the deep waters stop receiving fresh oxygen from the surface. The bottom of the ocean essentially suffocates. The deep sea becomes a toxic, oxygen-starved wasteland. As the deep marine life dies off, the entire food web collapses from the bottom up. The Earth will be hotter, yes, but the immediate killer of the global biosphere will not be the temperature. It will be starvation. And paradoxically, the plants won't starve because there is too much heat. They will starve because there is too little carbon dioxide. When volcanoes erupt, they release CO2 into the air. This gas acts as a blanket trapping heat. But as the Earth gets warmer, more water evaporates from the oceans, leading to heavier rainfall. This rain mixes with the CO2 in the atmosphere, creating a weak carbonic acid that falls onto the mountains and rocks. Over time, this acid dissolves the silicate minerals in the rocks, washing carbon down rivers and locking it away at the bottom of the ocean. It is an elegant, self-regulating loop. The hotter it gets, the more it rains, the more carbon is scrubbed from the sky, and the planet cools down. I tried to imagine what the world would look like in this era. The great green lungs of the Earth will collapse, leaving behind a brown, rotting landscape. There is a final desperate stand. A small fraction of plants known as C4 plants, like certain tough grasses and cacti, have evolved a more efficient way to process carbon. They will hold on for a few million years longer, clinging to life in the creeping deserts, but eventually even they will cross their threshold of survival. And here is where the dominoes fall. When the plants die, the herbivores follow. When the herbivores vanish, the carnivores starve. And without the plants to exhale oxygen, the atmosphere slowly loses its breathability. The oxygen levels plummet to a fraction of a percent, but the Earth itself will not die quietly. As the last of the macroscopic life perishes, the true wrath of the sun will finally reach the surface. The oceans, the very waters that birthed life, are about to face their own execution. And as we will see, when a planet loses its oceans, it loses its soul. The oceans, which cover 71% of the globe, begin to heat up. At first, the process is deceptively slow. The water cycle persists. Clouds form, rain falls, and rivers flow into the creeping deserts of Pangaea Proxima. But as the average global temperature pushes past 50 degrees Celsius, 122 degrees Fahrenheit, the rate of evaporation overpowers the rate of precipitation. More and more water vapor is pumped into the atmosphere. And here lies the fatal flaw. Water vapor is a greenhouse gas far more potent than the carbon dioxide that starved the plants. As the atmosphere fills with steam, it creates an impenetrable, insulating blanket around the planet. The heat from the sun comes in, but it can no longer escape back into space. This triggers a runaway greenhouse effect. For billions of years, the Earth has endured the slow brightening of the sun. For its entire main sequence life, the sun has survived by balancing two opposing forces, the inward crushing weight of its own immense gravity and the outward explosive pressure generated by nuclear fusion in its core. It is a perfect, delicate equilibrium. But at the 5 billion year mark, the sun runs out of its primary fuel. The hydrogen in the core is completely depleted, leaving behind a dense, inert ball of helium ash. Without the outward pressure of hydrogen fusion, gravity wins the tug of war. The core collapses in on itself. As it compresses, the temperature inside the core spikes to unimaginable levels, tens of millions of degrees. This sudden, intense heat ignites a fresh shell of hydrogen just outside the core. This shell burning produces far more energy than the sun has ever generated before. The sun begins to swell. It transforms from a stable yellow dwarf into a monstrous red giant. As the sun expands, its outer layers cool down, shifting its color from a blinding yellow-white to a deep, ominous red. But do not let the cooler temperature fool you. The sheer surface area of this new star is so vast that its overall luminosity, its total energy output, increases by a factor of thousands. First, it swallows Mercury. The tiny, iron-rich planet is incinerated in a matter of days, dissolving into the star's atmosphere without a trace. Next, it reaches Venus. Our sister planet, with its thick, toxic atmosphere, is consumed by the expanding plasma. The solar winds strip away its heavy clouds, and the rocky core is melted down into the stellar furnace. Then the edge of the red giant approaches the orbit of Earth. After consuming its inner children, the sun's final act is a quiet one. Unable to sustain fusion in its core, it sheds its outer layers in a beautiful, expanding cloud of glowing gas known as a planetary nebula. What remains at the center is the dead core of our star, a white dwarf. A dense Earth-sized diamond of carbon and oxygen that will slowly cool and fade over trillions of years. Our solar system will be unrecognizable. The inner planets are gone. The outer gas giants, Jupiter, Saturn, Uranus, and Neptune, will continue to orbit the faint fading light of the white dwarf in a cold, eternal silence. The physical story of Earth ends here. Consumed by fire, its atoms scattered into the Earth's timeline is a brutal reminder of the scale of the universe. It tells us that nothing, not even the ground beneath our feet or the star in our sky, lasts forever. But it also tells us that the universe produced something capable of understanding its own end. It produced us. The story of the Earth will eventually conclude, but our story is limited only by our imagination and our will to survive. And even if one day in the deep future we fade away, that is okay too. Every atom in our bodies was forged in the heart of a dying star. If the Earth is consumed, it is merely returning us to the cosmic forge. We are made of stardust, and it is only fitting that eventually we are reunited with the stars. Thank you for looking into the deep future with me. Stay curious, keep exploring. I am Tann for Y Zone 360.